At the top of the notes here, it has all of your perfect square roots listed for you. So these are ones that you're going to come across commonly, and you can actually type each one of these in our calculator. I don't know why, but it got rid of the square roots on all these. It's right on the paper, but I don't know why it's not showing up here. But anyways, you can type each one of those things into your calculator. You can pick any of them on here. Maybe we pick this one right here. Okay. If you want to type that into your calculator, to pull up a square root, you hit the second button, and then the button that has the x squared on it. If you see above it in blue, it has a square root. And then you can type whatever number you want to take the square root of. So that one that I picked for the chart was square root of 324. So I typed 324 underneath there. I hit enter. And it tells me that my square root is 18, just like the chart says. Okay? So, the top part of the chart, super easy, right? You can easily check those in your calculator. What we're going to talk about today is what happens whenever you put in a number that doesn't have a perfect square root, like some of these. Like maybe I picked the square root of 326, right? That's not on the chart, right? Okay, so that's what we're going to be talking about today, the ones that give us the funny decimals, and how can we simplify them. So, a decimal like this is what we call an irrational number. It's a number that's going to have a decimal that keeps going, and so at some point you've got a round, right? Even our calculator doesn't go on forever. It stopped right there. So, we don't want to get one of those decimals that goes on forever, so we're going to keep it as a square root or a radical answer, but we want to simplify it as much as we possibly can. So that's what we're going to do today. All right, so we've got this chart up here at the top, so we can reference it if we need to. All right, so in the first section, some of these are in our chart. What is the square root of 25? 5. And what's the square root of 169? 13. Good. And the square root of 441? Yes. Okay, so this part underneath here, according to our chart, is 21, right? But it has a negative in front. Remember, that's like a secret -1. Okay, so there was already a -1 out there. We're saying this part became 21. Well, I wouldn't just leave them there like a list, right? They're right beside each other. When numbers are right beside each other, what does that mean they want us to do? Multiply. Very good. What is -1 times 20? -21. So that would be our answer. So if you've got multiple numbers on the outside, you multiply them together. All right, so here's another example. We've got 2 square roots of 144. Okay, so I've already got this 2 on the outside. What does square root of 144 become? 12. So I get to take it out from underneath there, and it's just a 12. What do I do with that 2 and 12? Multiply them. So what would it be? Nice. Okay. All right, here we've got a negative in front. Remember, that's like a secret -1, right? So I've got -1. And then I've got square root of 1/64. So what I want us to do is split that up. Think of it as a square root of 1 over a square root of 64. Okay? We're taking the square root of both pieces, not just one of them. Okay, so what is the square root of 1? 1. According to our chart, it's just 1. And we had that -1 in front. Okay? And what's the square root of 64? 8. So we've got -1 and 1/8. And what do I do with those numbers? What do we do with them? Multiply, right? So I've got -1 times 1/8. What's -1 times 1/8? -1/8. Okay, here, same idea. I've already got the 5 out in front. Remember, we're going to take the square root of that top number and the square root of that bottom number. All right? Okay, so what is the square root of 169? 13. Okay, so I've got 13 in the top. And what's the square root of 225? What is it?
3.
There we go. All right, so I've got my 15 here, right? And what do I do with that 5 that was already in front? Multiply. So I've got 5 times 13 over 15. What's that going to give us? What's 5 times 13 over 15?
13 over 3.
Good. Remember, we can always multiply those in our calculator if we don't want to multiply the fractions by hand. Very good. Okay, so all of these above, we were able to come out with a nice and neat number, right? All of them were ones from our chart up above. But like I said, sometimes we'll have numbers under there that aren't from our chart, and if we type them in our calculator, it's going to give us a decimal. So that's what we're going to look at next. That's what it says here. It says, all of those first examples had a perfect square root. All of these in this table up here, these are called perfect squares, because they work out nice and neat to give us these whole numbers, no decimals. All right? But in this next section, we're going to be having some that don't do that. They give us what I told you guys we call an irrational number, which is a decimal that just keeps going. Okay, and we don't want one of those decimals, so we're going to simplify it as much as we can ourselves. All right, so is square root of 63 on our chart up there? No. So it's going to give us a decimal if we put it in the calculator, so we can't just put it in the calculator. What we're going to do is ask ourselves, what multiplies to give us 63? You guys think of anything? Okay. All right. What about 21? Is there anything you guys can think of that multiplies to give us 21? 7 and 3. Okay. So let's see if we can break anything down that's left. What multiplies to give me 7? Is there anything besides 7 and 1?
No.
No. What about 3? Anything besides 3 and 1? Okay, so we've broken them all down as much as we possibly can, right? Okay. But these are all numbers that are underneath a square root right now. In order to take them out from underneath a square root, you have to have a pair. And let me tell you why we have to have a pair. So here, we said the square root of 4 was 2, right? Because 2 times 2 equals 4. Here, we said the square root of 9 was 3 because 3 times 3 equals. So, I have to have a pair of 3's to equal this 9, right? So, underneath here, I'm looking for pairs, just like we would be up there. Do we have a pair of any numbers? Yeah, which one do we have? 3's. We've got a pair of 3's. So if I can find a pair like that, just like in the chart above, that means you can take it out from underneath the square root. Okay? So here, these two have a pair. If you can find pairs, then they can come out from under the square root. So I've got one pair of 3's. That means I can take out 1 3. So I'm going to take a 3 out from underneath there. But it's got to be a pair if you're going to take it out. Okay, is there anything that didn't have a pair? The 7, right? The 21 was gone because we split up. So the only thing left here is the 7. Okay, so because this one has no pair, it's going to have to stay underneath. All right, so I'm going to still have a square root of 7. Okay, so let's try another one. Remember, our goal here is to find as many pairs as we can, right? Okay, so let's see. We got 98. What might multiply to give us 98? 2 and good. Okay, so she said we should split this into 2 and 49. All right. Can I break 2 down any further? What about 49?
Yes.
Into what? Not 9, that's 98. Right idea though, it is this perfect 7 and 7. Okay, so 49's gone, we turned it into 7 and 7. Can we break the 7s down any further? Okay, so we've broken it all down as much as we can. Do we have any pairs? Yeah, what do we have a pair of? 7s. Okay, and what do I get to do if I find a pair? Pairs get to what? Come out of the square root. So I get to take a 7 out of the square root. Did we have any that were left without a pair? The 2. Where does it have to go? Inside. So there's my simplified answer. All right. Okay. Got another one here. Square root of 256. Does that one have a perfect square root? What's that from our chart? So remember, this is what we call a perfect square. Because this is just a whole number. No square roots, no decimals. Okay? All right, flip it over onto the back. We just got a couple more to look at together. All right, so number 10. We've already got a 2 out in front. Is 48 on our chart? No, so we're going to have to break it down ourselves. What can you guys think of that would multiply to give us 48? 2 and 24, I heard some others. 6 and 8, good. Any of those will work. You can pick whichever you want, because when we break it all down at the end, we'll all end up with the same numbers. Okay, so what did you say, Seth? 2 and 24? Okay, we'll go with that. All right, can I break the 2 down any further? No. Okay, so the 2's done. What about the 24?
Yeah.
To what? 2 and 12, okay. So now the 24 is gone. You guys said we can't break 2 down anymore, right? What about the 12?
6 and 2.
6 and 2. Okay. What about the 6? 3 and 2. All right, so do we have any pairs? How many pairs? We've got 2 pairs of 2. Yes, we've got 4 items all together that match. So we only circle pairs, so you can only put them in groups of 2. So I get to take 1, 2 out because of this group, right? I get to take another 2 out because of this group. And there was already a 2 on the outside, right? So we got 3 2s that are now on the outside. What did we say we do with all those numbers when they're out here? Multiply them, right. When we have a list right beside each other, we multiply. Was there anything left that didn't have a pair? The 3. So that means the 3 stays underneath, right? Okay, so now I just need to multiply these numbers together. What is 2 times 2? 4. And 4 times 2? 8. 8. Good. So we would end up with 8 square root of 3. All right? Okay, so if you want to make a little note of that, if you have more than one pair, multiply them. Just like we did here. Okay? All right, on this next one. So we've already got this 5 out in front, but we got to take care of that 72. Is 72 on our chart? No. Okay, so we got to break it down ourselves. What multiplies to give us 72? What is it? Perfect, that'll work. Okay, she said 2 and 36. Okay, can I break the 2 down anymore? No. What about the 36?
Yeah.
To what? 6 times 6. Okay. If you want, 6 and 6 is a pair, right? You could stop there, or you can keep breaking them down, and then you just end up with more pairs that end up multiplying back to the 6. Okay. So you could stop right there because you found a pair. Okay. If I find a pair, what do I get to do with it? Bring it out and multiply. Yeah, what's already outside that I'm going to be multiplying it by? The 5. So I've already got a 5. I'm going to multiply the 6. Was there anything that was left over without a pair? They're 2. All right, so there on the outside, we got 5 times 6, which is going to be 30. So we end up with 30 square root of 2. Okay. Let's see here. We got 216, not on our chart, right? So what multiplies to give us 216? What did you say? Okay, and yeah. So both of them work just like before. Either way works. When we work them all out, we're going to end up with the same pairs. So whichever works for you, you can pick whichever you want. If we do the 2 and 108, we know the 2 is as far as it goes, right? Okay, but what about the 108? What could I split it into? Okay. All right. Again, we know the 2 can't break down anymore, but what about the 54? Okay, 2 and 27. All right, so 54 is done. What about the 27? Close, that's 24. 3 and 9, okay. All right, can I break down the 3 anymore? No. What about the 9? 3 and 3. All right, so I've now broken down everything as much as I can. So let's see, do we have any pairs here? Yeah, we got a pair of 2s and a pair of 3s, right? Okay, so I get to take out a 2 and I get to take out a 3. What am I going to do with them? Multiply them. Very good. So on the outside, we're going to have 2 times 3, which is 6. Good. All right, what about the leftovers? Did we have anything left without a pair? A 2 and a 3. So both of them have to go underneath. But again, we don't just make a list of them, right? Just like out here, what am I going to have to do with them? Multiply them. And what is 2 times 3? So underneath there, I'll have a 6 as well. Okay, so these 2 were the ones with no pair. So 2 leftovers. You also multiply them together, but you have to leave them under the radical. Underneath that square root. Okay? So, we break it down as much as we can. If you find a pair, you take it out. If you don't find a pair, it stays underneath. Okay.